Hello everyone, welcome to my YouTube channel. Today we have to solve example number 8. Find the equation of straight line which is perpendicular to the line 5x minus 2y is equal to 7 and passing through the point which is midpoint of the line joining these 2 points 2, 7 and minus 4, 1. Here we have to find out equation of straight line. That required straight line is perpendicular to this line and passing through midpoint of these 2 points. Okay. So let slope of required line whose equation we are finding is m and which is equal to given by minus 1 upon m1, where m1 is slope of line 5x minus 2y is equal to 7. And you know formula for slope of line minus 5 divided by minus 2. So this is equal to minus that becomes plus 5 upon 2. M1 is 5 upon 2. Then what will be M? M is equal to minus 1 upon 5 upon 2. And this is equal to minus 2 divided by 5. We are assuming point x1, y1. This is midpoint of the line joining 2, 7 and next point is minus 4, 1. Okay, which is given by 2 minus 4 divided by 2, which is x coordinate, and 7 plus 1 divided by 2, which is equal to, we can write 2 minus 4 minus 2 divided by 2. That is minus 1, 7 plus 1, 8 divided by 2, 4. Okay. Required line passing through this point and its slope is minus 2 upon 5. Then applying slope point form, which is given by y minus y1 is equal to m into x minus x1. So y minus y1 is 4 is equal to m is minus 2 upon 5 into bracket x minus x1 is minus 1, so minus plus 1. Simplify this. This gives, taking cross multiplication, 5 into y, 5y, minus 4 into 5, minus 20 is equal to. Now minus 2 into x, minus 2x, minus 2 into plus 1, minus 2. Take all terms on one side, that becomes 2x plus 5y minus 20 plus 2, that is minus 18. So after simplification, equation of required line is 2x plus 5y minus 18 is equal to 0. Now next example number 9. Find the equation of straight line which is perpendicular bisector of the line joining the points A 8, minus 1 and B 6, 3. Here we have to find out equation of straight line which is perpendicular bisector of the line joining these 2 points. So let us assume L1 is required line and L2 is perpendicular bisector of line AB. Now assume point P x1, y1 is midpoint of line AB. Then coordinates of this midpoint, x coordinate will be addition of x coordinates of A and B and divided by 2. That is 8 plus 6 divided by 2. And y coordinate of this midpoint, addition of y coordinates of A and B and divided by 2. Minus 1 plus 3 divided by 2. Now simplify this. This is 8 plus 6, 14 upon 2 is 7. Minus 1 plus 3, 2 upon 2 is 1. Now we are assuming slope of line L1 is m1 suppose and slope of line AB is m2. Okay. Slope of line AB which is given by difference between y coordinates divided by difference between x coordinates. This is equal to 3 minus 1 divided by 6 minus 8. So this becomes 3 plus 1 divided by 6 minus 8 is minus 2. So 4 upon minus 2 which is equal to minus 2. Hence m2 is minus 2. But we know required line L1 is perpendicular to L2. So by the condition of perpendicular lines, m1 into m2 is equal to minus 1. So m1 is equal to, taking this m2 on this side, minus 1 upon m2. But m2 we have obtained minus 2. So this can be written as minus 1 upon minus 2, and which is equal to half. Okay. We know slope of line which is half and the point through which that straight line is passing. Hence, applying slope point form, y minus y1 is equal to m1 into x minus x1. Put the values and get the answer. So, y minus y1 is 1. This is equal to m1 is half, x minus x1. x1 is 7. Simplify this, taking cross multiplication, 2 into y is equal to 2y. Minus 1 into 2, minus 2. This is equal to 1 into x. 1 into minus 7, minus 7. Okay. Take all terms on one side. That gives x minus 7 minus 2y plus 2 is equal to 0. Minus 7 plus 2 minus 5. So, after simplification, required answer is x minus 2y minus 5 is equal to 0. Let us solve next sum, example number 10. Find the equation of the line passing through the point of intersection of lines x plus y is equal to 0 and 2x minus y is equal to 9 and point 2, 5. Means required line passing through point of intersection of these two lines, and one more point lying on the straight line is 2, 5. Means 2 points lying on the straight line are given, and hence we have to find out equation of straight line. Okay. So assume x1, y1 is equal to point of intersection of the lines x plus y is equal to 0 and 2x minus y is equal to 9. To get the point of intersection of these two lines, you can use calculator. To find the point of intersection of these two lines, this and this, we have to solve these two equations simultaneously. Okay. First of all, we have to go in equation mode. Yes, this is equation mode. Number 1 is equation mode. And there are two equations, means there are two unknowns. So you can select 2. Now a1 is coefficient of x of first equation, that is 1, is equal to coefficient of y, which is b1, which is also 1, is equal to constant term which is appearing on right hand side, which is 0, is equal to. Now a2 means coefficient of x of second line, which is 2, is equal to b2 means coefficient of y of second line, which is minus 1, which is equal to c2 is constant term which is appearing on right hand side of second equation, which is 9, is equal to x coordinate of point of intersection is 3, and now again equal to means y is equal to minus 3. So 3 comma minus 3 is point of intersection of two lines x plus y is equal to 0 and 2x minus y is equal to 9. And second point which lies on straight line is x2 comma y2. x1 comma y1 is 3 comma minus 3 and x2 comma y2 is 2 comma 5. Then we know 2 points lying on the straight line. Hence, equation of straight line passing through points x1 comma y1 and x2 comma y2 is given by the formula y minus y1 divided by y1 minus y2 is equal to x minus x1 divided by x1 minus x2. So x1 y1 and x2 y2 we have to put in this equation. So we can write y minus y1, and here y1 is minus 3 divided by y1 minus y2 minus 3 minus y2 is 5 is equal to x minus x1. x1 is 3 and x2 is 2 divided by x1 minus x2. Simplify this. Hence y plus 3 divided by minus 3 minus 5, that is minus 8, is equal to x minus 3 divided by 3 minus 2 is 1. Taking cross multiplication, we can write y plus 3 is equal to minus 8x minus minus plus 24. Taking all terms on one side, means minus 8x is taken on left hand side, that becomes 8x. 24 also taken on left hand side, that becomes minus 24. So, and after simplification, that gives equation of required line, which is given by 8x plus y minus 21 is equal to 0. Okay. So, here you can write 8x minus 24 plus y plus 3 is equal to 0. and this is nothing but this one. So this is solution of given sum. Let us solve next sum number 11. Find the equation of the line passing through the point of intersection of the lines 2x plus 3y is equal to 13 and 5x minus y is equal to 7 and perpendicular to 3x minus y plus 7 is equal to 0. Means what is given? Required line is passing through point of intersection of these two lines and perpendicular to this line. By using the condition of perpendicularity, you can find slope of the required line and one point which lies on the required line, that will be point of intersection of these two lines. And now we have to solve this sum. Let x1 comma y1 is equal to point of intersection of the lines 2x plus 3y is equal to 13 and 5x minus y is equal to 7. So point of intersection you can find solving these two equations simultaneously. So let us solve these two equations. We want equation mode. So yes, number one is equation mode. There are two equations, means two unknowns, so you can select 2. Now a1 means coefficient of x in first equation, that is 2, then equal to coefficient of y in equation 1 is 3, which is b1 is equal to c1 means constant term in equation 1, which is 13 is equal to a2 means coefficient of x in equation 2, which is 5 is equal to b2 means coefficient of y in equation 2, which is minus 1 is equal to c2 means constant term in line 2, which is 7. Now equal to, that gives x coordinate of point of intersection of these two lines, which is 2. Okay, x is equal to 2, which is x coordinate. Now again press equal to sign on calc, that gives value of y, which is equal to 3. Means 3 is y coordinate of point of intersection of these two lines. Now let m1 is equal to slope of required line L1 and m2 is equal to slope of line L2. L2 is suppose 3x minus y plus 7 is equal to 0. This line. Slope of this line, which is m2. So minus coefficient of x divided by coefficient of y. Applying this formula, m2 is equal to minus 3 divided by minus 1. And this is equal to minus minus plus 3 upon 1 means 3. m2 is equal to 3. But required line L1 is perpendicular to line L2. So m1 is equal to slope of line L1 is equal to minus 1 upon m2. And you know m2 is 3. So slope of line L1 is minus 1 upon 3. m1 is equal to minus 1 upon 3 and straight line passing through this point. So here we have obtained slope of the line and point lying on the line. We can apply slope point form to get the equation of straight line. Here L1 is perpendicular to L2. Hence using the condition of perpendicular lines, we have obtained m1 is equal to minus 1 upon m2 and which is equal to minus 1 upon 3. Okay. Now by slope point form of straight line, y minus y1 is equal to m1 into x minus x1. Substitute x1 comma y1 here and as well as value of m1. So y minus 3 is equal to m1 is minus 1 upon 3 into x minus x1. x1 is 2. Simplify this. 3y minus 9 is equal to minus x plus 2. Simplify this taking all terms on left hand side. That gives x plus 3y minus 11 is equal to 0. And this is answer, which is equation of required line. Let us solve example number 12. Find the equation of the line passing through the points 6, 5 and parallel to the line which makes intercepts 2 and 4 on the coordinate axis. Okay. Here what is given? Given that the line whose equation we have to find out is passing through the point 6, 5 and parallel to the line which makes intercepts x intercept 2 and y intercept 4 on the coordinate axis. Hence let L1 be required line, L2 be the line which makes intercepts 2 and 4 with x-axis and y-axis respectively. So x-intercept is 2, y-intercept is 4. So let us find equation of L2 first. Applying two intercept form, x upon x-intercept plus y upon y-intercept is equal to 1. Now taking LCM after simplification, this gives straight line L2, 2x plus y minus 4 is equal to 0. This is equation of line L2. But L1 is parallel to line L2. Whatever may be the slope of this line, that will be slope of line L1, which is required line. So let us find slope of this line. Assume M1 as slope of line L1, M2 as slope of line L2. So slope of line L2 is equal to minus coefficient of x divided by coefficient of y. That is minus 2 divided by 1, which is equal to minus 2. But what is given? Line L1 is parallel to L2. Hence, slope of line L1 must be equal to slope of line L2. Hence, we can write M1 is equal to M2 is equal to minus 2. So, slope of required line is minus 2 and point lying on the straight line is also given, means required line passing through the point. That point is 6, 5. Hence, one point lying on the line and its slope we have obtained. So, using slope point form, which is given by y minus y1 is equal to m into x minus x1. But here m is nothing but m1. Here substituting x1, y1 and m1. x1 is 6, y1 is 5 and m1 is minus 2. Hence y minus 5 is equal to minus 2 into x minus 6. Simplify this and take all terms on one side. So 2x minus 12 is equal to, this is minus y plus 5. 2x minus 12 is equal to minus y plus 5. Now take all terms on one side. Hence 2x plus y minus 12 plus 5, taking on this side, that becomes minus 5 is equal to 0. Hence required equation of straight line is 2x plus y minus 17 is equal to 0. This is required answer. Let us stop here. Thank you. Thank you for watching this video. Thanks.